Hi, Geo 110 Online. I'm just going to give you just a little intro to the Metamorphic Rocks Lab. Just to give you a heads up, right now I am in the exercise Metamorphic Rock Identification, exercise 1. So this exercise is going to be using samples 17 through 24. So we're looking at this portion of the tray, okay? And we're looking at these 8 specimens here. So this one, 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 okay? So in the first step, it says use the hand lens to identify the grain size of the rock according to the descriptions and record your answer below. Fine grain, medium grain, coarse grain. So I'm just going to go ahead and give you some examples of what fine grain versus coarse grain are going to look like. So if I go ahead and I take a close look at number 17, I'm going to bring it up to the camera. This is number 17. See if I can focus a little better. A little hard to focus with this. I can see that number 17 has some pretty big crystals. If I look close enough at it, if I bring it up to my eyes, I can see basically it looks like sugar crystals. So number 17, that might be considered coarse grain. We could consider number 17 coarse grained. Then if I take a look at another sample, like for example, sample 19, that's got some pronounced foliations in it. We'll talk about that in just a second. Let's take a look at number 23. 23, there's no grains to be seen, okay? And what do grains look like? If you've ever seen sugar clumped together, like for example, number 21 would be medium grained, because like think about it as like clumps of sugar crystals, okay? Like a sugar cube or something like that. If it looks like big sugar crystals like number 17 does, that's going to be coarse grained. If you don't see any like sugariness, if it doesn't look like brown sugar at all, we could say fine grain or no crystals. Then let's talk about foliations. Foliations are banding in the rock. Number 17, your 17 should look something like my 17. And 17 is the most clearly foliated. We have different types of minerals creating the bands. And so, like, for example, number 17 is very clearly foliated. Sometimes foliations aren't quite so clear. So if we look at number 19, in this case, we're looking at you may have a mix of dark and light. Look predominantly at the dark. This also has foliations. It doesn't have it actually does have a mix of several minerals, but they're not creating those big, thick, nice bands. The model of banding, the model of foliation is really number 17. But if you turn it on the side, it looks like sheets. In the case of metamorphic rocks, those sheets are also considered foliations. So the table they give is pretty good for this. So it's embedded directly into the lab. And you're mostly looking at foliations versus grain size. Now there's another aspect they don't really get into in detail, but it is important to consider. So when it says composition, that's the minerals you're going to be finding. And to figure out the minerals on this one, if you grab your mineral kit, the 2 parts of your mineral kit that you will need for this are your glass plate, which is this guy, and your acid, which is this guy. And really what these are measuring, so the acid is a test for calcite. If it fizzes, then calcite is present. The glass plate is a test for hard silicate minerals that includes quartz and feldspar. So really this is your quartz and feldspar test. If it fizzes with acid, then it's probably calcite, or in this box, it's definitely calcite. In these 8 samples, if it scratches glass, then you're expecting to see quartz or feldspar present. Now, there's minerals other than quartz and feldspar that will scratch glass, but quartz and feldspar are the big dominant minerals you are going to be finding in metamorphic rocks. So just because a mineral scratches glass doesn't mean that it's quartz. But in this box, for these 8 samples, it's a good guess that it involves quartz. So let's go ahead and take a look and analyze and identify number 17, number 18, and number 19 together, and then the remaining 5 you can do. So number 17 is probably the easiest. It's a signature metamorphic rock that I use a lot in my classes. I put the glass plate down because they gave you for over $300. This is not a great glass plate, but whatever's. Put it down on a flat surface and give it some elbow grease. And you'll notice that with number 17, if you gave it enough elbow grease, it should scratch glass. And then we can say, aha, there's probably quartz and feldspar in number 17. Because it does scratch glass, I don't even need to do this because calcite won't scratch glass. But if I put a drop of acid on it, I see no fizz. So it's coarse grained. It's got, in other words, it's got big crystals. It's got pronounced foliation. Quartz and feldspar are present. Calcite is not present. So if I look at my chart and I look for the foliated ones, and I look at the medium to coarse, and I look at the descriptions, 2 of them have quartz and feldspar, that's schist and gneiss. So I look at the description, scaly foliation versus gneissic banding, visible crystals and alternating light and dark layers. If I look at this guy, I can probably say, okay, this is probably closer to clear band. Like, this doesn't look scaly. What they mean is that it looks like it's in thin layers is scaly. That's not this guy. I don't see thin layers, but alternating light and dark layers, this guy is gneiss. Now let's do the same thing for number 18. I've established that it has got, if I look at it, it's probably medium grained. Okay, my sample, your sample may have larger or smaller crystals. This actually comes in a range of different crystal sizes. I put my glass plate down, I scratch it, I don't see a scratch. That means that it probably doesn't have any quartz or feldspar in it. I put the acid on it, I see plop, plop, fizz, fizz. That tells me there is calcite in it. So what am I looking for? And there's no banding in it. If I look at the crystals, they're all about the same size and there's no particular direction. It really looks like, mine in particular really looks like a piece of sugar, like a chunk of a sugar cube. So I look at my chart, I'm looking for non-foliated. So I look at the ones that are non-foliated. That includes amphibole, hornfels, anthracite, marble, quartzite, echolite, and metaconglomerate. I look at grain size. Mine is medium. So any of the ones that say fine to coarse, fine to coarse, fine to coarse, medium to coarse. So now I'm down to marble, quartzite, eclogite, and metaconglomerate. And then I look at the composition. And of those 4, marble, quartzite, eclogite, and metaconglomerate, only one of them contains calcite. And that one is marble. So number 18 is marble. Going to do the same thing with number 19. So I'm going to take a look at this. look it up close. I'm going to say that this is maybe a medium grain, maybe a fine grain. I can see that in there. We'll call it a fine grain. Yeah, pretty fine grain, fine to medium. So it's definitely foliated. We have that looks like layers going on top of it. Does it scratch glass? Yes, it does. So it probably contains quartz or feldspar. So the ones that I'm looking at, I've got slate, phyllite, schist, gneiss, possibly amphibolite. All of those contain quartz. All of those are foliated. It's finer, so we're probably looking at more of the slate or phyllite. So I'm going to look at the descriptions of the slate and phyllite. One is slaty rock cleavage, smooth, dull surfaces. And the other one is wavy foliation, glossy sheen. Now take a look at the black portion or the dark colored portion, and I can see you want to hold this up to a light. It helps to hold it up to the natural light. So my office has a nice window now. So I hold it up to the natural light. And what do I see? I see a certain level of glossiness. So with that description, probably my best guess would be a phyllite. However, based on the description, I would also take a schist for this. Those are closely related. And some of these are going to be closely related. Couple of tips on the remaining specimens. Those little chunks in here, those little, like, you're going to see little, look almost like little tiny chocolate chips, like brown chocolate chips. That's actually garnet that you're looking at in there. So you're going to want to look for something that might contain garnet. This one over here, pay attention to whether it fizzes. Number 21 fizzes or scratches glass. And it's non-foliated. This one over here, you can see if there's clear banding. For this one over here, check if it scratches glass. I assure you it will. And once again, if you have repeats, some of these will fit in multiple families. Like gneiss is a big family. Schist is a big family. They present it here as a single rock, but really there's whole families of gneiss. There's whole families of schist. So if I see a lot of schist and gneiss, that's not a bad thing. Tip for number 23, pay attention to the fact that it kind of looks like a piece of coal. That's just a hint. And for number 24, what's making it glitter like that is mica. So with those hints, that should make this identification process a little bit easier. Now let's turn to the lab itself. So let's take a look at exercise 2. I'm going to be honest, the only portion of this that makes sense is the data table 4. So that's what I'm going to focus on explaining right here. I'm going to write Science Interactive. If you do not want to complete data table 1, 2, or 3, you're fine, okay? Because they're not providing a sufficient amount of information. Like they give this zone map, and this is graduate level stuff. So the fact that Science Interactive careens wildly between kindergarten level and graduate level is not ideal, and I'm trying to rewrite these, but I'm one stressed out geologist teaching 6 classes. So we're going to make this work. This is data table 4 is what I expect my students to be able to complete. So data table 4 is what I'm going to be focusing on right now. So in data table 4, you need to describe the grade of your rock, and I'll just give you a glance at it over here. The grade of the rock name, the grade, and the protolith. And that's something we do in class in Geo 110 in person. So where are you going to get that information? So here, this table, table 3 on exercise 2, this is going to have what grade you're looking at here. So slate, firelight, schist, nice. Okay. I noticed that they did not include, assume that things that are not included in this list are all low grade. So you have a sample of marble in your tray. The marble is low grade. The anthracite is in your tray. That is also a low grade metamorphic rock. Quartzite can also be considered a low or intermediate grade metamorphic rock. So if it's not listed in this chart, it's low grade. Let's do it number 17. 17 we positively identified as nice. Nice lands clearly in the high grade. It's actually the highest grade metamorphic rock. Any silicate rock that's granite, other metamorphic rocks like phyllite or schist, mudstone, slate, sandstone, granite, anything with enough quartz in it, if you put enough heat and pressure on it, it is going to turn into nice. So you have to identify the grade. You get the grade from this chart right here. How do you identify the protolith? The protolith is actually hidden over here under metamorphic grade in the exploration. It's this chart over here. So this is table 1, protoliths and metamorphic grade. If I look up nice, these are the protoliths they list. You can put any of these protoliths. In our region of the North Country, the dominant protolith of our gneiss is granite. But mudstone, shale, sandstone, like I said, anything with a certain amount of quartz in it, you squeeze it long enough, hard enough, and under enough heat, that dude is going to turn into gneiss. Gneiss is the end result of high grade. It's actually what we find at the base of mountains. If you've ever wondered what's on the inside of a mountain, take a good look at number 17. You're looking at a chunk of the inside of a mountain. This is something that forms under, for example, when you have continental collision. So, for example, in our region, we have a lot of gneiss that formed under the continental collision 1.1 billion years ago in the formation of Rodinia. Okay, so that should give you, you're just really going to be doing data table 4. You're going to be using table 1 from the exploration under explore metamorphic grade, and you're going to be using in the experiment protoliths and metamorphic grade to identify the grade, this table. Do not worry at all about data table 2, data table 3. The information they're giving you is what they're trying to do is teach you something about metamorphic facies. But they're not giving you, I feel, sufficient background to really understand that topic. And I really consider metamorphic facies more of a Geo 131 topic anyways. So we're not going to worry about those two tables. We're just going to worry about Geo 110 topic. What is a protolith? What is grade? What do I mean by grade? By what I mean by grade is how much heat and pressure it's been under. And they don't really go into it, but also something called stress it's been under. In other words, directional force. If you can identify that, then you are well equipped to teach in an elementary school classroom, which is the goal of a lot of the students in this room, or to get a gen ed because you are a criminal justice or business major. So if you have any questions, don't be afraid to ask. Once again, on the second part, really just focus on data table 4. If you want to give 2 and 3 a shot, that's great. But I'm not even going to be grading it because they just do not give you a sufficient introduction, I feel, to achieve that. And we don't even handle that in Geo 110 at the college. So good luck. Know that I'm always here to help you. Know that I'm always here to guide you. If you get really confused, if you want to walk through anything, I'm happy to help. My voice is back. And namaste and have a great day.